How's it going, y'all? Today we are doing graphing linear equations. So more SAT problems. We're going to go through all these. I recommend you do them before I do. And then use my work to check your answer. And maybe find another way to do it. So what is the deal with linear equations? The deal with linear equations, the gist of it is you've got your slope, which is your m, and your y-intercept. That's the biggest thing. And so when we're looking at this problem, they tell us the line passes through the origin. So we know it's going through 0, 0. That's going to be our y-intercept. And it has a slope of 1 over 7. So what that tells us, there's two things about the slope. One, which we're not going to use here, is that the slope is how much the y changes. So remember delta, the triangle, that means change. So the change in y when the change in x is 1. So that's true in this case. So when x goes up by 1, y is going to go up by 1/7. So that is 1 point. When x goes up by 1, y goes up by 1/7. But we don't need to think about that here. That's kind of too much, actually. So what do we need to think about here? What we need to think about here is the other way of looking at slope. Is that this is how much y changes when x changes by this much. So when we think about that, that's telling us y is going up by 1 when x is going up by 7. So that's not going to be totally to scale. So maybe we'll put it up here. Goes up by 1 when it goes over by 7. So that's the point. X went over by 7. Y went up by 1. It'd be a lot easier to see if we had graph paper. But the SAT doesn't provide us graph paper. So that would be a point on the line. 7, 1. But that's not an answer choice. So to get another point, we're just going to have to do it again. We're going to have to go up by 1 again and over by 7 again. So we went over another 7. So now we're at 14. We went up another 1. So now we're at 2. So that would be D. So that's just counting out the slope. We could, of course, go the other way as well. If some answer choices were like that, we could go down by 1 and then over this way by 7. And what would that be? Well, we went to the left 7, so -7, and we went down 1. That would be another answer. All right, let's do this one. So they talk about this a lot too, parallel lines. So with parallel lines, they have the same slope. I think that's kind of the best way to think about it. So here, I would think about this is going over 5 and up 2. And we know this other line has to have the same slope. And we see it's going up 4. So how much does it have to go over by? I mean, we could set up proportions that 2 over 5 equals 4 over x. But hopefully you can see that it would have to go over 10. Okay, next. The graph of a line in the xy plane has a slope of 2 and contains the point 1, 8. The graph of a second line passes through those points. If the two lines intersect at A and B, what is the value of A plus B? So there's a couple ways to do this. My jump to is to write equations. That's what I would do if I was on the test. But it might be easier to try to just graph it out and see. Let's do that first. So it would be way easier again if we had graph paper. But we don't, so let's label the points. We have the point 1, 2, and we have the point 2, 1. Do your best to keep it to scale, but it's impossible to be perfect, so don't try. And then we have that line. So let's just sketch that line. Let's change colors. So then we have the other line that goes through 1, 8 and has a slope of 2. So that looks something like that then. And again, it's not to scale, but we can roughly see where that point's going to be. We know it's going to be somewhere on the left side. So let's just count out points until maybe we find ones that match. So let's look at the pink line first. So we got to just see the pattern. Look how every time x goes down by 1, y goes up by 1. So then we know we have the point 0, 3. X goes down by 1, y goes up by 1. And then maybe this point right here, 1, 4. All right, that's a decent guess. Let's look at the other line. So the other line has a slope of 2, right? So that tells us that when we go over 1, we're going to go down by 2. So that's the point 0, 6. And then if we did that again, we go down by 1 and over 2 again, we do see we hit the point 1, 4. So what is the value of a plus b? Where they meet? They meet right here at 1, 4. Ah, but no, I messed up the signs. Right. It's not 1, 4. It's negative 1, 4. Luckily, they didn't put that as an answer. So then the answer is 3. But now that I've done this problem, I'm remembering the other ways to do it. The way to do it is to look at this pattern with this slope. Every point on this line, they add up to 3. So if you know that the point you're looking for is on the line, and it's got to be on that pink line, you know they're going to add up to 3 just right from that. So that's really the way to look at it. We don't even need to write equations. I'm sure we'll have to do that at some point later on. All right, so 25. So this is an interesting kind of thinker problem. So we got the graph of a linear equation has the intercepts, a comma 0 and 0 comma b. A plus b equals 0, and a is not equal to b. Which of the following is true of the graph? Okay, so we know we have our intercepts. So let's start drawing. We might draw wrong things at first, but we'll start drawing. So we know we have this point here at a comma 0. Which one's a comma 0? This one's a comma 0 because the y coordinate is 0. And this one is 0 comma b. Okay. So what else do we know? We know that a plus b equals 0. So right now we have that wrong, right? Because in this case that we drew, both a and b are both positive because they're above and to the right. So a plus b is not going to equal 0. For a plus b to be 0, one's going to have to be positive and one's going to have to be negative. So here's one circumstance you could have where b is negative. So that's 0 comma b. So notice that we don't write the negative. It's just that it's negative. B is negative, so it's going to put it down there. The other option is that a is negative and b is positive. So those are the two options here. And look at it, in both of those options, there's one thing that's similar. The slope is positive. In fact, I think they're both positive 1. If a and b they have to add together to be 0. So there we go. Slope has to be positive. All right, what's going on here? So we got to write an equation of a line, looking at the answer choices. Which of the following is an equation of the line that passes through B and D? Okay. Well, one thing we know, which we can see if we draw that line, the diagonals of a square are always going to be perpendicular. So we know those have to be perpendicular. So then the other question is, what's the slope going to be if those have to be perpendicular? Well, you know that perpendicular slopes. So if one slope is, say, a over b, the perpendicular slope to that is going to be the opposite, so negative, reciprocal, b over a. So what we're going to do is we're going to find the slope between c and a. Or actually, since they tell us e, we're going to find the slope between c and e. And then that'll give us the perpendicular slope. So what's the slope between c and e? So it looks like it's going from 7 to 1. Well, the y is first, right? So it's going 2 minus 0, which is 2, over 7 minus 1, which is 6. So that slope is 1/3, which means this slope is going to be negative 3 over 1, the slope of the line we want. So let's see. That gets rid of those. right? Because it's not negative 1/3, it's negative 3. And then what point do we need it to go through? We need it to go through 1 comma 0 here. So I just want to plug in points and see. So if we plug in 1 here, we do not get 0 for y. But if we plug in 1 here, we do get 0 for y. So it has to be that one. B. Let's see, could we have just done that from the beginning? Yeah, that's the only one that you can plug in and plug in 1 and get 0. So we suppose we could have just done that from the beginning, if that has to go through E. Because if it goes through B and D, it has to go through E. Nice. Plugging in points is so useful sometimes, especially just when you notice it. All right, so this line, where K is a number, is graphed. If the line contains the points C and D, what is the slope in terms of C and D? Okay, so here we're going to plug in, not the answer choices, but this point, because that's the X and the Y value. So we'll go D equals K times C plus 4. And they want us to find the slope. So what is the slope? The slope is the K, right? Because that's where the M would normally go in the mx plus b. So we got to solve for K. So we just got to subtract this 4 over and then divide by C. So D minus 4 over C. A. Very nice. All right. So the line determined by these points passes through the origin. Which of the following could be K? Interesting. Interesting. So let's do... Well, we can start by finding the slope. So do K minus 32 over 2 minus K. That's the slope. I mean, how I would do this is I would then go to write the equation of the line. So this is something we haven't talked about yet today. Point-slope form. Point-slope form is the slope times x minus the x coordinate equals y minus the y coordinate. It comes from just the formula for slope. The m is y2 minus y1 over x2 minus x1. And then you like cross multiply. Multiply both sides by that. So that's where the formula comes from. And that's what we're going to use for something like this. Or at least that's what I'm going to use for something like this. I'll use the first point. So 2 and K. So we do that. And then, so that's the equation of this line. Like in terms of K. But then what we can do is that we know it has to pass through the origin. So we can plug in 0 for x and y. And then that will just get us something we can solve for K. So that'll get us negative 2 times K minus 32 over 2 minus K equals negative K. And that's not bad, I suppose. We'll just cancel out the negatives. We'll cross multiply and distribute at the same time. I suppose it's a negative K squared plus 2K equals K minus 32. Oh, we do still have that 2 though. So 2K minus 64. And then just move everything to the right. So K squared. Oh, and the 2Ks cancel. That's what's nice. So it's K squared minus 64 equals 0. So K equals plus or minus 8. 8. Okay, that was a fun problem. I'm remembering how I did that other ways. Let's do it another way because maybe you'll find that easier or less tedious. So the other way I did it was I started the same way. I said that I found the slope between those 2 points. And then I said that has to be equal to the slope between like those 2 points. So K minus 0 over 2 minus 0. And then from there I cross multiplied. And you see that that would get us the same thing. We cross multiply and we would get to that step right there. So that is definitely easier. That's definitely less steps. Saying that because you know if they're on the same line, the slopes between them all have to be equal. So you find the slope between those 2 points, find the slope between the origin and one of those points, and those have to be equal. All right, let's do another. This is a long section. It's okay. I think it's 3 or 4 pages. So let's do this one. Let's change colors. I guess that's pretty similar. Let's go brown. Brown is nice. which of the following equations represents a line that is parallel to that line? So if it's parallel, they need to have the same slope. That's all we care about. And we should be able to look at these and really know the slope without having to write stuff down. So like if you look at A, notice to know the slope, you've got to put it in y equals mx plus b form, which basically means get the y by itself. So in A, if you try to get the y by itself, what would you have to do? You would have to subtract the 6x to get negative 6x on the other side, and then divide by 2. So you'd have negative 6x divided by 2. That would be negative 3x, which means that's parallel. That has a slope of negative 3. Just for practice, let's look at the other ones. So B, if we wanted to get y by itself, well, you just have to add y to the other side and subtract 7. That'd probably be the easiest way to do it. So that would have a slope of positive 3. For C, you'd be adding the 3y. You subtract the 6. We're not even thinking about the y-intercept though, right? We're just thinking about the slope if it has to be parallel. So we'd add the 3 and add the 3y and divide by 3. So that would have a slope of 2/3. D, we'd subtract the 3y or subtract the x and divide by 3. So that would be negative 1/3. But yeah, luckily for us, it was A. All right, the next one. So this line contains points from quadrants 2, 3, and 4, but no points from quadrant 1. Which of the following must be true? So let's just sketch it out. So you got to know the quadrants, but that's quadrant 1, and then it goes around this way because it's like the angles. When you talk about angles, you go around that way. And so it says it's got 2, 3, and 4. So basically, if it's a line that's going through 2, 3, and 4, it's going to have to look something like that, right? There's no other way for it to go through all of those and still avoid quadrant 1. So what must be true? We'll look at the line. The slope is negative. You can't draw a positive slope. You can try to think about how you could draw a positive slope that goes through those 3 quadrants, but not the first one. But no, there's no way you can do that. If it has to be a straight line, and it says that, right? The line. So, yeah. All right, next one. Nice and easy. You just graph the equation. So anytime I'm thinking about graphs, I often like to start at the y-intercept. So negative 5, we're looking for a y-intercept of negative 5. So definitely mark off A and C. And then what? Then you got to look at what's different. Once you get down to 2 answer choices, look at what's different. One's got a positive slope, one's got a negative slope. Our line has a positive slope. So we're looking at D. No need to be any more specific than that. So same here. Well, none of these have a y-intercept, so I wouldn't start with that. All we're talking about is the slope. So we've just got to find the slope of the line. So when they give you something like this, and you got to find the slope of the line, look for 2 points. Actually, all of these points are perfect, right? I was going to say look for perfect points, but all the points are perfect. So just see what's happening. It's going up. Make sure you look at the scale. It's going up by 10 when it goes over by 20. And it's definitely positive. It's positive 1/2. B. There we go. So yeah, look for perfect points and just find the slope between those perfect points. Often it does, like, not every point goes through the grid. So when I say perfect points, I mean find ones that go through the grid. All right. We got 3 more pages. So what's going on here? The growth rate of the sunflower from day 14 to day 35 is nearly constant. So it's a line. On this interval, which of the equations best models that line? So let's see, day 14 to day 35. So let's just look at it on the graph first. So they're talking about right there. Let's sketch out the graph. So then we can see, at least roughly, where the y-intercept is going to be. Looks like it's definitely going to be negative something. Okay, they're all negative. I would say it's going to be bigger than negative 20, right? I think we did that roughly to scale, and 20 would be right here. So I'm pretty confident if we had to. I'm pretty confident with that being B. But let's look at the slope, because we can actually get that perfectly. I'm pretty sure this is a calculator question. Maybe we'll use the calculator here. Because don't realize that data table goes to the graph. So we can just look at those points from the data table and then find the slope between those points. So that's going to be 131 minus 36.36 divided by 21. 35 minus 14. And that does indeed get us a slope of 4.5. So it is indeed B. Okay. The graph of a line passes through the point 1, 4 and crosses the x-axis at 2, 0. The line crosses the y-axis at the point 0, b. What is B? So, let's see. That point and that point, 2, 0. Is that the y-intercept? No, that's the x-intercept. So, I would write the equation of the line. I'm always looking for better ways to do it, but that's just straightforward. That's how I would do it. So I would write the equation of the line. So I'd find the slope first. The slope is 4 minus 0 over 1 minus 2, so negative 4. And then we're going to write the equation of the line. It has to go through, I'll use the point 2, 0 equals y minus 0. And that's the equation of the line. See, once you get good at it, it's quick enough anyway. And then now you can just plug in the point, because you know when x equals 0, y has to be b. So we're going x equals 0, negative 4 times negative 2 equals y, equals positive 8. So positive 8 has to be the answer. All right, and the xy plane, notice how they always say that. They just mean in the graph and the xy plane. A point that is not on here, not shown, with the coordinates s, t, lies on the graph of the linear equation. It's on that line. If s and t are positive integers, what is the ratio of s to t? Well, it's going to have to be just the same as these, right? That's probably the idea. We'll try to do some math to back that up. But it's just going to have to be like 3 over 6. So 1 over 2. So I'm pretty confident, but let's do some math to back that up. The math I would do to back that up is I would write the equation of the line. So we can see that it's going up 6 when it's going over 3. So that's a slope of 2. 2 over 6 over 3. So the slope of 2. So the equation of the line is y equals 2x. We can confirm that when we plug in 3, we get 6. Yes. And then if s and t are on the line, so then we're working with t equals 2 times s. They want to know what is the ratio of t to s. Oh. Hang on. Ratio of t to s means you're going to be dividing both sides by s. I'm getting t over s equals 2. When I do it out, did I do it wrong the first time? S to t or t to s. Right, because they're asking about t to s. That's why I did it wrong. T is double big than s. I did. Ooh. Good thing I did it out. So yeah, 2 to 1 because it's t to s. I think I just read it wrong because s is definitely 1 when t is 2. And yeah, you see right here I did s to t, where it was supposed to be t to s. So yeah, definitely make sure you're paying attention to that. Okay, here we go. What is the slope of this line? So I would just look at the points, and maybe this is counterintuitive, but I would look between these points because they're both fractions. So then you're not converting back and forth. You can just say like, how much did it go up? And see how it, like, when you think about fractions, one way to think about it is kind of like a unit. So right here we have negative 27 fifths, and it's going to 3 fifths. So how far did it go up from negative 27 to 30? It went up 30 fifths, right? And then how much did it go over from negative 6 to 9? It went over 15. So, just simplify now. So obviously 30 over 5 is 6, so we're looking at 6 over 15, which is 2 over 5. So the slope is 2 fifths. Yeah, and I think that's just easier than trying to use that middle point, even though it might look cleaner. And we could even confirm that. I don't know why I'm unconfident about this answer. But if we wrote the equation for this line, we have the slope now. We can easily see the y-intercept. And then maybe we can plug in points and confirm. So, that is kind of nice. If we plug in the 5 halves, this just cancels out and we get 1. So it's 1 plus 3. Oh, right. It's not plus 3, it's minus 3. So we get 1 minus 3, which is negative 2. So yeah, we're pretty confident about that line working with the slope being 2 fifths. All right. Easy, easy peasy here. Just write the equation of the line. Make sure we got the variables right just in case. So m is our x and d is our y. Yes. So what is the slope? The y-intercept is 0 for all of them. It's going up 2 and over 1. The slope is 2 with a y-intercept of 0. Beautiful. Easy, easy. All right, next. Which one has a slope of 3? My goodness, easy, easy. Slope-intercept form. Z, C. 27. In the xy plane, the point P, R lies on the line y equals x plus b, where b is a constant. The point with the coordinates 2p, 5r lies on the line with the equation 2x plus b. P is not 0. What is the value of r over p? Okay, so I would plug in here. I would plug in and get two equations. Remember, any point is x comma y. So that means we can say that b plus b is equal to r. And remember, this is a different line. So 2 times 2p, so 4p plus b equals 5r. Okay. So some may be tempted to do substitution here, but I wouldn't, because look at how we want r and p. We're looking for r over p. We might not actually find what they're equal to. We might just find what their ratio is. And we don't want the b, basically. So what I would do here is I would subtract. I would do 5 minus 4p is negative 3p. B minus b is 0. And r minus 5r is negative 4r. And then look at what you want. You want r divided by p. So then I say you got to try to build that. So we're going to divide both sides by p. You see, there's our r over p. We just got to get rid of that negative 4. So we divide both sides by negative 4. So those negatives cancel, the p's cancel, and you get r over p is 3/4. And that's what we wanted. That's our answer. So there might be a way to just think about it and see it, but that's what I would do. If you write out equations, you can just solve them. That's why I always like writing out equations. All right, in the xy plane, the equations x plus 2y equals 10 and 3x plus 6y equals c represent the same line for some constant c. Okay, so you know the same line, it has to everything be the same. So let's take this first equation and multiply it by 3. That way we see that it's 3x plus 6y equals 30. Just because then we can compare, and that just shows us that c is going to have to be 30. Right? Because they're the same line. You make the left side the same, so then the right side's also got to be the same. All right, here. So this is not a linear equation, is it? What's it doing in this section? The graph of the function defined by that quadratic equation is shown in the xy plane. If the function not shown is defined by g of x equals negative x plus 10, there's our linear equation. What is one possible value of a such that f of a equals g of a? Okay, so think about that. You want the functions to be equal. So that's like system of equations ideas. That's like where they intersect. So let's graph the line g of x. That's why it's a linear equation, because that's what we have to deal with. So how do you graph a line? Y-intercept, and then the slope is negative 1, so down 1 over 1. But make sure you look at the scale. You've always got to look at the scale, because they're not equal here. So to go down 1 and over 1, that's going to put us here. And then, so there's our line. We just have to do more points and see that that's where it intersects at the point 2, 8. So what are they asking for? What is one possible value of a such that they're equal? 2. Because f of 2 equals 8 and g of 2 equals 8. And just for fun, look how there's definitely going to be another answer. You've just got to keep going until you get there. So you draw more points on the same pattern, and there's the other answer. And wouldn't you know it, it's 8, 2. So 2 or 8 both get you the right answer. All right, which of the following systems is true about the graph 2y minus 3x equals negative 4? Negative slopes. So they're talking about slopes and y-intercepts. So let's try to do it without doing anything. So to get the slope and the y-intercepts, we got to get the y by itself. So to get the y by itself, I would add the 3x to both sides to make it positive, and then divide by 2. So the slope is going to be positive. But then, see, the y-intercept it's already a negative 4. So when we add the 3x, that's going to stay negative. I guess I can write it out. 2y equals 3x minus 4 Now we're going to do the divide by 2. So we're getting 3 halves x. That's positive. That one is going to stay negative. So D. All right. The graph of the linear function is shown in the xy plane. The graph of the linear function g not shown is perpendicular. Oh, remember perpendicular, opposite reciprocals. Passes through the point 1, 3. What is the value of g0? Okay, so we know it passes through this point, and we know it's perpendicular. So I can sketch that out. It's going to be something like that. But let's see, what is the actual slope here? So the slope of this line is -1, or negative, no, it's going down 2 and over 1. The slope of that line is -2, which means the slope of the perpendicular line is 1/2. So remember that other definition we said for slope, that slope is how much the y changes when x changes by 1. So if we're thinking about this new line we're trying to draw, when x goes down by 1, y is going to go down by 1/2. That does look more perpendicular, don't you think? Yeah. So, where is it then? 1/2 isn't the answer. It started at 3 and it went down 1/2. So 2.5, or 5 halves, would be the answer. All right, last page. That wasn't too bad. The line M contains the points 2, 4 and 0, 1. Which of the following is an equation of M? So we could write it out, use point slope form, except for actually, we have 0, 1. That's the y-intercept. So that's really just going to give us the answer here, ain't it? It's just going to be D. Because 0, 1 is a y-intercept, so slope-intercept form. That's the only one that has a y-intercept of 1. What I was going to suggest to do anyway is plug in the points. Either plug in x equals 2 and try to get 4, or plug in x equals 0 and try to get 1. And you can see for sure when you plug in x equals 0, D is the only one you're going to get 1 for. So the answer is definitely D here. Okay, so this is just a weird question in general, but so let's take a minute to read it. So Jennifer bought a box of crunchy grain cereal. The nutrition facts on the box state that a serving size of the cereal is 3/4 cup and provides 210 calories, 50 of which are calories from fat. In addition, each serving of the cereal provides 180 milligrams of potassium, which is 5% the daily allowance for adults. So we might not need all that information for this question, but which of the following could be the graph of the number of calories from fat and crunchy grain cereal as a function of the number of 3/4 servings of cereal? So it's number of servings, because each serving is 3/4 cup. That's what they're saying by that. So it's number of servings on the x-axis and calories from fat on the y-axis. So all you need to think about here is if you're having 0 servings of the cereal, how many calories are you getting? How many calories are you eating if you're eating 0 servings? You're getting 0 calories. So you know that you need the point 0, 0 on the graph. And by golly, there's only one graph that has that point. So that's all we need to think about here. All right, 3 more. In the xy plane, the line L has a y-intercept of -13 and is perpendicular to that line. If the point 10, B is on the line, what's the value of B? Okay, so new slope. This is the old slope. We want perpendicular, so opposite, which means in this case, we're going to make it positive, and we're going to flip it, +3/2. So that's the slope, and they actually tell us, oh, wait, so is that the line we want? Line L has a y-intercept of -13. Yeah, so we'll use slope-intercept form. 3/2 x minus 13 equals y. And then this point. So they give us a point. That always means we can plug it in. And that's what we're going to do. So we're going to plug in x equals 10. So 3/2 times 10 minus 13. And that equals b. Because see, now we just have an equation. We can just solve it for b. So cancel. Make that 5. 3 times 5. 15 minus 13. B equals 2. So notice how important that's been for all of these, is seeing the point and plugging it in. That it's always x and y, so you can always plug it in for x and y. Oh, wow, which of the following is an equation of the line? So I would plug in points. Notice how these are not in slope-intercept form already. So say that when we plug in x equals 0, y would have to be -4. So let's see, when we plug in x equals 0, and y is negative 4, that gets us a positive 4, not a negative 4. So A doesn't work. Let's see, if x equals 0 and ends up being plus 4, that works. If x equals 0 and y is negative 4, C works. If x equals 0 and y is negative 4, D does not work. So at this point, we're between B and C. And then what I would do here is I would think about the slope. We need a negative slope and see how with C, if we subtract the x to the other side, we're going to get a negative slope. Versus B, we would get a positive slope. So then it would have to be C. Alternatively, you could plug in this, that when you plug in x equals negative 4, y would have to be 0. And you could see that that does not work for B. So then it would have to be C. All right, last one. Some values of x and their corresponding values of y are shown in the table above, where a is a constant. If there is a linear relationship between x and y, which of the following represents a relationship? So again, I would plug in. They don't give you points here, they give you a table, but it's the same thing. So when x equals a, y would have to be 0. So let's see which ones those work for. So when x equals a and y is 0, that works. When x equals a and y is 0, that does not work. When x equals a and y is 0, that does not work. When x equals a and y is 0, that does not work. So right from there, it just has to be a. See how valuable plugging in points can be. Because then you don't have to do anything. You just eliminate the answers, especially when it's multiple choice. And those are all those problems. So I hope you did those along with me. I really like looking at them like this, of doing the same type of problems all in a row, because it lets you see how similar they are. Look how often we plugged in points. Look how often we just thought about the slope. Look how often we looked at the y-intercept when we were writing equations, and we were just determining between positive and negative slope a lot of the time. So like all of these problems, this is quite a bit of problems from the SAT, and they really just revolved around 2 or 3 similar topics between all of them. So next, we'll be doing another section. Which section is next? Let's look at our schedule. Next up should be reading graphs. So more talking about graphs. So if you want to get ahead, download my binder down in the description and like and subscribe so you'll see when I post those problems.